Hi, I'm Tony from Cycle Nuts, and today I'm going to talk to you about how to clean up the electrical accessory installs on your bike. The most common question I get from people that install electrical accessories on their bikes is how can they clean up the setups? You get one accessory going back to the battery, you've got one eyelet, good, nice and clean, easy to manage. You start getting two or three on there, you start ending up with a rat's nest back at the battery of multiple eyelets, bunch of wires. It's difficult to troubleshoot because you've got just a jumble of wires, and it's also a safety hazard back there. So what we recommend most often is going with a fuse block or distribution block. They go by different names depending on who you're talking to about it, but essentially they all do the same thing. You connect them to your battery, locate it wherever you want to locate it. We get people that locate them under the seat, side covers, fairings, tail trunk, wherever. And then you connect all of your accessories to these blocks. Nice and clean, everything comes back here. Fuses are all here, very easy to troubleshoot and very neat up at the battery. One connection and you're essentially done. The most common devices that we recommend are the Centec AP1, the Centec AP2, and the Fuzeblock FC1. All three of them are pretty cost effective. They all do things a little bit differently, so you're going to want to plan what you're putting onto them and how you want them to work. We'll start with the AP1, and basically the AP1 is a single device that connects to your battery. All of your accessories that connect to this, and this is always on. So what that means is if you walk away from your bike, leave your driving lights on, it's going to draw down your battery. If you have USB ports on your bike that charge up, maybe your phone, even when something isn't plugged into those, a lot of them have a little parasitic draw, so they're always going to take power from the battery. So with something that's always hooked to the battery, you're going to run the risk of possibly killing your battery. Now you can get around that by installing a wiring harness. Check out the size. And what this will do is make the AP1 turn on and off when you turn your ignition off. And basically a wiring harness connects to your battery and connects to a switch source. And what that does is activate the AP1 only when your key's turned on. Now the AP2, this is divided into effectively two devices. It's got a switched side and it's got a constant side. And what that means is, again with a harness, you hook this up to your battery, you hook this up to a switch source, brake light, accessory socket that's only turned on with a key on your bike. And when you turn the key on, some of the circuits, for our example here, we'll say these three are turned on. And when you turn the key off, these three are turned off, but these two are kept on. And what this might be good for is if you want to hook up a battery charger. When you turn your key off, you still want to be able to charge your bike. So you hook that up to one of the two that is powered constantly, and that will help you keep your bike charged up or any other accessory that you might want to use while the bike is on. Some people keep their GPS on there because they want to turn the bike off and do their thing with the GPS. So that's where the drawback is with the AP1 and a wiring harness, because if you want to hook a battery charger up to this, a battery tender, you turn your key off. If you're using a harness, this is dead. So you will have to hook up that battery tender up separately. Then we have the Fuzeblock FZ1, and this does similar to what the AP2 does, whereas it has a switched and a constant side. But the neat thing about the Fuzeblock is that it's got a built-in relay. So that means you don't have to worry about putting a big wiring harness back to the bike. You have a power that goes to the battery, a negative that goes to the battery, and then you have something that goes to the switched. The relay is all here, and that's what controls the switched and the constant circuit. And another neat thing about this is the way that those circuits work. It's got 3 rows here. If you want a circuit to be constant, you put the fuse in one section. We'll put it over here to the right. If you decide you want that circuit to be switched and only be active when the bike is turned on, you just move it over there and it's done. It's switched. The AP2, if you wanted to change how a circuit functions, you have to physically move the wires from another port to another. The fuse block, all you do is move the fuse from one to the other, and that circuit functions differently. So that's neat. That's a nice tidy install. 3 wires. Like I said, you don't have to worry about all of this. You have the AP2, which would require a harness to work that way. And the AP1 is an all or none. And you can see with the AP2 and the AP1, these function similarly as far as how they're designed and made. They have 5 fuses. They have 8 circuits. So what this means is you can hook 8 devices up to this, but you only get 6 fuses, or 5 fuses. So what that means is some of them are doubled up, and if you blow one of the fuses, then that's going to blow both of the devices that are on that circuit. So best practice is 1 device per port, in my opinion. So that would mean 5 on here. Fuse blocks, this has 6 connectors on here. So that means you can hook 6 accessories. AP2 and AP1, they both have 8 potential accessories, 5 fuses. Something else to keep in mind is the limits. Depending on what you're drawing, some of these might be good for your application and some might not. If you have something that's going to draw a lot of power, the AP1 is the one that's going to enable you to draw the most power. This whole block is capable of 60 amps total. So what that means is for all of the circuits, all of the accessories, you can draw a total of 60 amps, split it up amongst the fuses however you want, and then it'll work for you. AP2, on the other hand, is split up into 2 systems. The max for the block is 60 amps, but it's split up into a 40 amp section and a 20 amp section. So if you have something that's going to draw more power, you're going to want to put that on the 20 or 40 amp section. Lower power ones go on the 20 amp. The fuse block is a total of 30 amps for the whole block. Any one circuit can be 10 amps. So, you could have a 10 amp circuit, a 5 amp, 5 to 7.5, just so it doesn't exceed the max of 30. Wire those up however you want, but don't exceed 30. These have a total of 60. The AP2 is split up. The AP1 is all one unit. They're all similar in size. We have the AP1 and the AP2, which are exactly the same size. The AP1 and AP2 are 3 inches by 2 1/4 by 1 1/4. So again, that's 3 inches by, 2.5 by 1 1/4. Those are the size for the AP1 and the AP2. The fuse block is 3 1/4 by 2.5 by 1 1/4. So, a little bit different size. You're always going to want to check your location, make sure you've got enough clearance. They come with standoffs for mounting so that you can bolt them to whatever you're going to mount them to, be it plastic or metal. The fuse blocks comes with an extra plastic plate that you can put between the block and metal if you're mounting it to metal, so that you lessen the chance of risk. You can make up your own for the AP1 or the AP2, it's up to you. So again, these are the 3 most popular blocks that we recommend, most popular ones for any of the people that come in, and they've all got a little bit different features. So like I said, before you do your install plan, know the limits and design your system after that. If you've got Any questions on any of them, they're all on the website. They've got all the specs, measurements, everything there. So feel free to click on the links below and you'll be able to see them on the website. If you want to get notified of more reviews that we do, subscribe to the channel, click on the notify, and you'll get a notice when we post our next review. Thanks for joining me.